Okay, we're going to work for some baby algebra. We start with adding, subtracting, multiplying, dividing fractions here. So people call this a butterfly method. So when we add two fractions like this, we could think this way, multiply those two numbers, 1 times 3, we get 3. Then 2 times 4, we get 8. Right? Then the operation is plus. So we add the numerators. So 3 plus 8, that's 11. What do we do with the denominator? We multiply those two numbers. So 3 times 4, 12. It's exactly the same as making common denominators, right? The common denominator of 3 and 4 is 12, right? So thinking another way, let me erase this. Let's do another way of thinking, another way of doing this. So we need a common denominator of 12, right? So the first one, I like to call 1 transformers. So 1 and 0 are transformers to me because 1 equals any number divides itself. And later on, we're going to use 0 for some other things. 0 equals any expression subtract itself. So those two, like transformers, you can change the two numbers to be anything, right? 1 can be, for the first one, and we multiply by 1, but this 1 is 3 divided by 3. 3 divided by 3 is 1, right? Because 1 multiplied by any number still is the number. It doesn't change the value of the number. But I need 3 divided by 3 because I need denominator to be 12. And same thing for 2 over 3. I need to multiply 1, but this 1 is a 4 over 4. So in this case, the first one, 1/4 becomes 3 over 12. And 2 over 3 becomes 8 divided by 12. And we call 1/4, 3/12 equivalent fractions. Same thing for 2/3 and 8/12. They are equivalent fractions, right? Let's just mix them. Let's see, 1/4 equals to 2 over 8. I multiply by 2 over 2 equals to 3 over 12 equals to 4 over 16. The list keeps going, right? Or I can multiply 25 over 25, seem to be 25%. So those are called equivalent fractions. So you see this way also I get same answer, right? 3 plus 8, because once I have a common denominators, the operation here is only for the numerators. So I don't change the denominator. The denominator stays to be 12. I don't add the denominators. Once I have common denominator, I keep the common denominator. The operation addition is for the numerator. 3 plus 8, that's 11. So why is that? Right, think about a pizza pie, right? I cut 1/4. I cut four parts. I cut 4 parts. Then I take one of the 4 parts. This is the 1/4, right? Or I can cut the same pizza pie by 3 parts. Right, just imagine this equally 3 parts. And then I take one of them. That's 1/3. So how do I add those two together? Right, I want to add those two together. How do I add that? I need to make them same slices. I need to slice them the same way. So that means I need to slice again this into 3 more equal parts. I need to slice each one into 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Now I have 12 slices. And these 3 slices. So this 3 out of 12 slices now. Same thing for this one. I need to cut each one into 4 slices. I need to cut this each 1/3 into 12 slices. So this 1/3 is 4 out of 12. Now I can add them. Before I wouldn't be able to add directly, right? 1/4 add 1/3. I won't be able to add directly, but now I can because they are divided by same slices. Okay, same slices. Oh, hold on a second. Right, but for this one is 2. For if I have to do this question, that's 2. I take 2 of this, right? That becomes 8/12. Okay, so now let's use the quick method to do this. For subtraction, the same thing. You know, if you want, you can go over to, you can go this way to multiply by 1 for each one, right? But I want to use butterfly method. I multiply those two. 6 times 7, that's 42. 5 times 8, that's 40. Then the operation is subtraction. So I'm subtracting the numerators. 42 minus 40, that's 2. Then multiply 6 with 8, that's 48. Now I see numerator and denominator both even numbers. I can divide by 2. 2 divided by 2, I get 1. 48 divided by 2, I get 24. So I get a 1/24 for 3. Now let's move to 2. 2 are adding 3 fractions. Well, let's just add 2 first. Multiply these two, I get 15. Multiply these two, I get 16. My operation is addition. So 15 plus 16, I get 31. 4 times 5, get 20. Then I add 2, the second one. Let me change my color to be red. So I do that again, but the numbers may be too big to do that. So what else I could do? I can simplify this proper fraction, right? Because 31 divided by 20, I can simplify. I can rewrite 31 as 20 plus 11. 20 plus 11 divided by 20. Well, then you see 20 divided by 20, that's 1. So I can write as 1 plus 11/20. Then I add 3/8. Okay, this way is much easier to do that. 11 times 8, I get 88. 3 times 20, I get 60. My operation is addition, so I just add 88 plus 60 is 148. Divided by 20 times 8, 160. And also, I cannot forget about this 1. I still have this 1, right? I can write as 1 plus because I want to simplify this. This can be simplified. How do I simplify? I can divide by 2 first. If I divide by 2, 148 divided by 2, I get a 74. 160 divided by 2, I get an 80. Oh, still even numbers. I can divide by 2 again. I can divide by 2 again. So 74 divided by 2, get 37. 80 divided by 2, I get 40. Now, 37 is a prime number, so the only factor is 1 and itself. So my answer is 1, 37, 40. So mixed fraction. Or if we want to write as improper fraction, we can change this one to be 40/40. 40 plus 37 is 77/40. Okay, either one is fine. Okay, so that's those 4 questions. Let's keep going. I have 2 more. Let me erase all this. Okay, now let's see what I want to multiply. So number 4 is multiply. I have to move this down a little bit. So let's see number 4. Number 4, I'm multiplying those 2 fractions, and the second fraction is a mixed fraction. So there are 2 ways of doing this. One way is we can always think, so this is 2/3 times, we can always change the proper fraction as the whole part plus the fraction part, right? Because this just means 1 plus 3/4. Then we multiply. Then when we multiply, we get a 2/3, because 2/3 times 1 is 2/3. Then we multiply 2/3 with 4 over 3. So 2 over 3 times 3 over 4. Now we see 3 over 3 becomes 1. 2 and 4 can be simplified as half. So left with 2 over 3 plus half. Right, butterfly again. 2 times 2, 4. 1 times 3, 3. Operation addition. 3 plus 4, 7. Denominator 3 times 2, 6. Okay, so this is one way, but I'll show you another way. Another way, we change the mixed fraction into proper fraction, to improper fraction. Okay, so how do we do that? So this 1 means 4 over 4, right? So we will do 1 times 4 plus 3. So 2 over 3, we keep writing. And now 1 times 4, that's 4. 4 plus 3, that's 7. So 1 and 3/4 also is 7 over 4. In this case, you see the beauty of this. We can simplify 2 and 4. That's a half. Then nothing can be simplified. 1 times 7 is 7. 3 times 2 is 6. We can get to the answer quickly in this case. Okay, now let's see 5. 5, we're going to change this to be improper fraction. So we multiply 7 with 2 plus 1. Well, that's 15. Then divide by 2. Divide by a fraction has changed to be multiplication of its inverse. Its inverse is 5 over 3. Inverse means multiplicative inverse here. Okay, let's use a simple example. Let's see, if I have 10 divided by 2, and we know that's 5, right? But also we can think as 10 multiplied by the inverse of 2. What's the inverse of 2? Inverse of 2 is half. 10 times half, indeed, that's also 5. So 2 times half equals to 1. So that's why we call 2 and a half multiplicative inverse with each other. 3 times 1/3, 2/3 times 3 over 2. You know, any two numbers, when you multiply to be 1, they are inverse with each other. So when we divide by a number, it's the same as multiplying by its multiplicative inverse. So we use that idea to do this for fractions. When we divide by 3/5, it's the same as multiplying by its inverse, and its inverse is 5 over 3. We just flip the numerator and denominator, right? Why is that? You see this case, the numerator multiply, we get 6. The denominator multiply, we get 6. 6 over 6 indeed is 1. Okay, so now we can simplify 3 with 15, right? 3 goes into 15 5 times. Now the numerator will have 5 times 5, which is 25. Denominator will have 2 times 1, which is just 2. If we have to convert into proper fractions, we want to break 25 into 24 plus 1. Because 24 is a multiple of 2. So 24 divided by 2, that's 12. By half. It's just 1 divided by 2, that's half. And we write it as proper fraction, mixed fraction, as a 12 and 1/2. Now let's see 6. So 6, the numerator will have 3 plus 4 minus 2. Denominator will have 2 plus 1 minus 5. Right? So 3 plus 4, that's 7. 7 minus 2, that's 5. The denominator is 2 plus 1 is 3. 3 minus 5, -2. But usually we don't want to leave the negative sign in the denominator or in the numerator. We put up front. As long as one of it, the numerator or denominator is negative, so that means the number is negative. So we leave like this, -5 over 2. Let's see 7. How do we multiply decimals? So in the beginning, we want to forget about the decimal places. We just multiply the numbers. So we focus on the number. With number of 2 times 1. Well, what's 2 times 1? That's just 2. Once we finish that, we count how many decimal places we have. The first one have 2, The second one have 2. So 2 and 2, that's 4. So we count from 2, right? Think 2 is like decimal place here, 2.0. But we need 4 of them. So that's 2, 3, 4. Then we put 0 point. You see I have 4 decimal places, 0, 0, 0, 2. So that's the answer for this. Let's see, 8. We're adding decimals. So when we add decimals, we need to line up the decimal points. So 4 is before the decimal point, 1 and 2. Then we add 5 plus nothing, that's 5. 2 plus 2, that's 4. 0 plus 1, that's 1. Decimal point, keep writing it. 0 plus 4, that's 4. So that's the answer. The answer is 4.145. But sometimes maybe we don't have space to write. If we don't have space to write, we would do the same. We would multiply 0, not multiply, we would add 0 with 4 because it's before decimal. We would add the 10th place, right? Then the 100th place, then the 1000th place. Or if there's no number, there's just 0. All right, so those are some baby algebra. Hope this makes sense.